My name is Jeff Johnson. I'm with the MAPE Corporation. I'm what's called a product manager or business manager for the floor covering installation systems. It's all wood adhesives, resilient adhesives, and so on and so forth. My esteemed colleague John Namba is joining me today. All of you may know him. He's got quite a length of accolades, master craftsman of all vertical types of flooring, CFI associations, World Floor Covering Associations, senior technical editor at BNP. Did I pull that right?
Not senior.
Oh, come on, be senior today anyway. Make it sound better. It sounds good. All right. Anyway, John and I have collaborated on other projects. I'm very excited about having him part of this team as well. A couple of housekeeping things to keep you apprised of today. Before we get started, please silence your electronic devices. This sounds like a little bit of an airplane read, but I will jump and try to answer your phone because I figure it's a sale or something I need to go after, so please turn that off. Please complete the evaluation form, so show management will have your suggestions and directions when planning next year's program, and by all means do accolades for John and myself. We'd love to come back and do this again. For those of you seeking continuing education credits, there are sign-in sheets and self-reporting forms available at the table outside. Audio recordings of this conference session, which is a great idea in case you want to take it back and give it to somebody else, with synchronized PowerPoint presentations are available for purchase at the Fleetwood sales desk located on level 2. And stop by the event bookstore brought to you by the Marvel Institute of America to purchase the latest industry resources and books. For more information about anything I've mentioned, see the room monitor, which is right outside the door, or refer to the event guide or mobile app. And I hope you enjoy this session and have a great experience of the show. We hope to see you at the International Surfaces Event East in Miami in October, which is in my backyard. So please, by all means, do come in. That was... yeah, sure, why not? It's lovely in Delray Beach, a few minutes from the ocean. It's great fun. All right, so again, welcome. I'm glad you're here. I got through all the administrative stuff. What we're going to be doing a little bit today is giving you some information relative to subfloor preparation for wood, flooring, and bamboo. And the way we're going to break this apart for you today is do a separation by the general categories of subfloor, concrete, and wood. In my particular instance, I have the expertise in the concrete, and John's going to handle the wood. So we're going to run through it a little bit in the middle. John will take over and do the last half, and we have a lot of good information to get through, so please hold your questions to the last of the presentation. I think this is self-explanatory. In the first half of this presentation, hopefully you will be able to understand the 4 basic tenets of wood floor insulation over concrete substrate, identify recommended products and systems available to remediate concrete substrates with or without moisture problems, understanding the various techniques and methodologies for preparing concrete surfaces to receive solid wood, engineered wood, or bamboo flooring, and to be able to select the right installation method for any given solid wood flooring over a concrete-based substrate or living requirements. It's a lot of stuff. So in order for us to get started, you kind of have to understand the enemy. In this particular case, the enemy is concrete. We talk about our basic tenets. First of all, we want to make sure the subfloors are clean, dust-free, free of any curing agents, parting compounds, bond breakers, paint residues, taco sauce, oils, grease, and other contaminants. Those things need to be removed, especially if you're going to bond stuff to it. You don't want to have anything that gets in the way of doing that. And hopefully you don't get to a job site that looks like that, but that's obviously not a suitable substrate to be working with. Need to be smooth and flat. With regard to requirements, the National Wood Flooring Association, who seems to be one of the industry standards for this, says that it needs to be 3/16 of an inch in a 10-foot radius. There's a very valid reason why that's important, especially if you're gluing flooring down on a surface like that. Most of the notches on the trowels that you use to apply these adhesives are not much more than 1/4 of an inch in height at a 45-degree angle. So you want to make sure that that floor is flat enough so when you marry the wood to the adhesive you get good enough strength. There are all different kinds of methods. We'll talk a little bit about how to fix those, but that's the requirement. There are some documentation, specifications written. This is an extraction out of an ACI 302 requirement for wood flooring, and here you'll see some requirements actually stated by, I guess, the now defunct Maple Flooring Association. Doesn't really exist anymore, is that correct, John? Maple Flooring? No. They exist, as well as the Wood Flooring Manufacturing Associations talk about the same kind of requirements, an 1/8 inch in 10 and a 1/4 inch in 10. Dryness. Okay, this is very important also. This has been one of the major issues with bonding wood flooring or putting wood flooring of any kind on a concrete flooring. Water and wood do not mix. The NWFA requirements of most flooring manufacturers recommend a 3-pound moisture vapor emission rate or 75% RH as maximum allowable moisture for any wood flooring installation. However, we know oftentimes that flooring is installed over a swamp. Hopefully we don't do that. One thing that's important to note, why is moisture? We all know that if you get water on wood, it's going to do all sorts of bad things. But here is an extraction. I don't know if you can see this clearly or not, but there is a great deal of information available to you on how wood responds to moisture. The National Wood Flooring Association provides this by wood species. And here are a couple of examples of what happens to the wood as its internal humidity changes from a 3% to from a 6% to a 9%, a 3% change on Brazilian cherry, a plank width of 5 inches, the length and the dimension of the room are 14 by 10. The actual expansion of that flooring in that area is going to be 1.5 inches in its length and almost 2 inches in width. This is a classic reason why we want to make sure you have expansion joints around the perimeter of the room when you bond things to allow for that kind of accommodation. Obviously, this is a pretty major swing in humidity, but that kind of thing can happen if you allow the air conditioning to go off on a vacation property and the humidity swings in the room. These are the kinds of disasters that can happen. I've actually seen pictures of wood flooring expanded so far it blows the walls out on the building because of that kind of expansion. American Beach, again, the same kind of thing, is a little bit more sensitive to moisture. The same room dimensions, same width plank can expand up to 2 inches in length and almost 3 inches in width. This is all kind of documented stuff. So this is why you need to be very careful about moisture and wood. Standards for concrete are very important to keep in mind of. Here are two very important documents. One we refer to quite a bit for the resilient floor covering market, the ASTM F710. I realize that's for resilient, but there's a lot of good information in there as well for anything that is moisture sensitive. And then the ACI is the American Concrete Institute 302.2R. There's a great deal of valuable information here. It's, the ACI document gives you a lot of good education on concrete as well, so I'd highly recommend you download those, gain access to them. They're great selling tools, quite frankly. When somebody's trying to ask you, well, why do I need moisture mitigation? Said, well, these standards say you need to have these kinds of things, and here's the proof, and here's the reasons why. A little bit more information about the ASTM F710. Of course, they are for resilient flooring, but it does do a lot about the determination of suitability of concrete flooring in terms of its compression strength, its flatness, its moisture content. It does provide some suggested construction methods for concrete slabs. This is where you're going to find information. I'll talk a little bit more about it, that moisture vapor barriers need to be put in place underneath the concrete, and some preparation methods for getting them ready for resilient floor covering installation, patching, leveling, and so on like that. Again, the guidelines that are presented in this documentation say, again, the same stuff we've always been talking about. It's got to be dry, clean, smooth, structurally sound. All the cracks and control joints should be filled and provide a minimum of 3,000 psi compression strength in 28 days. This talks about the integrity of the concrete. You're putting a very expensive, sometimes a beautiful product on the floor. You want to make sure you're not installing it on something that's going to crumble underneath you. Expansion joints, not so much a big issue for residential applications, but definitely in a commercial world, you cannot cover over those for obvious reasons. Surface must be cleaned, free of any adhesive residues whatsoever. We don't want to get in the way of anything bonding to it. It should be smooth and flat within that tolerance we talked about as well again. It's got to be clean. A lot of concrete is poured with some sort of a curing agent. In tilt-up construction, they use bond breakers to keep the slabs apart. The way to find out whether or not these exist, there's two ways to do that. One is the water drop test. Many of our MAPE tech service reps, when they go on a job site to take a look at a concrete slab, have a bottle of water with them, and they're kind of shaking it as they go along, and if it's not dropping on the floor and it's not absorbing, they know there's a highly possibility there's a curing agent or some sort of a bond breaker on top of it. Another way to do that is to take a drop of water and a piece of pH paper and soak the concrete area. If the pH paper comes out 7 or 7.5 or 8, it's still measuring the pH of the water. If water does come in contact with natural cement or concrete, the pH should be a little higher in the 11s, 10s, 11s, or 12 range. So a good way to test whether or not there's a bond breaker quickly is this water drop and a pH paper test. ASTM also calls out the necessity of moisture testing, as well as the National Wood Flooring Association has these called out in it as well. Moisture vapor emission rate tests, or on-site or in situ RH testing, and obviously pH testing. pH testing is oftentimes overlooked as a test method for looking at concrete slabs, but it's a very good preliminary indicator as to whether or not there is a moisture problem or not. If the pH of a test comes out higher than 12, in the 13 to 14 range, that generally means that there's an awful lot of water movement coming through a concrete slab, bringing up all the alkali salts that are within the concrete surface, creating a high pH. It's a very good indicator that you may have a problem with moisture, and you should do the rest of the tests. Basics for moisture measurement, the two tests that are recommended in the market for this category are the ASTM F1869 calcium chloride testing. We all should be familiar with that at this point. That's the little dome test. The calcium chloride disc measures the moisture vapor emission rate coming through a concrete slab and provides you information in relative numbers, 8 pounds, 1,000 square feet per 24 hours. And to give you some idea what that means, then 8 pounds per 1,000 square feet is 1 gallon of liquid water essentially coming through an area of a room that's 12 by 12 or 14 by 14 or something in that range. When you're dealing with floors that are 25 pounds of water coming through that 25 pounds, which are very fresh concrete, new concrete, it's essentially 3 gallons of water coming out of that concrete slab in a 24-hour period. So it's not something we would do on a regular basis, to come into a concrete slab and throw 5 gallons of water on the floor and expect to be able to have anything stick to it and perform. RH testing is relatively new to the industry. Not relatively new. It's within 5 or 6 years of doing this. This is the probe test that is put inside a concrete slab, and it basically is designed to give you a relative benchmark as to the state of cure of a concrete slab. Concrete does lose its humidity as it continues to cure, so high RHs mean the concrete is relatively fresh, or it could be an indicator that there's a lot of moisture vapor coming through it. The lower the RH number, the more humidity is gone, typically the older the concrete slab as well. The two do not correlate. That's always been something we need to make sure you are aware of, but they are good indicators of moisture. In my opinion, the calcium chloride testing is a rate value. It gives you some information of how much is coming through on an overall basis, and the RH testing is pretty much a state of cure. What does the concrete slab look like at that particular time? Again, in the ASTM F710, they do give you some suggestions on concrete slab construction, particularly on grade. And here's where we talk about having compressed soil, a loose aggregate, a capillary break, a polyethylene layer, and then the slab laced on top of it. And they do make some mention to make sure that landscaping is down below the level of the floor, so you do not wind up with hydrostatic pressure or water ingress because of landscaping or sprinkling or weather conditions. We've all seen some very bad stories or heard bad stories about berms that were set outside the building, water runs down, and then you've got massive failures around the edge of the room because of that exterior water. The ACI 302 mimics or presents a lot of the same information that the F710 does, but it does get into a lot more detail on concrete curing. And again, I'm trying to not bore you too much with concrete technology, but you need to understand what you're dealing with, what kind of animals we're dealing with, before you start putting wood flooring on a sponge, for lack of a better description. The general knowledge base is that a concrete slab that's 4 inches thick, that's made with a 0.5 water to cement ratio, will take approximately 3 months to get to a suitable level for wood flooring installation. That's what this chart is. That's the moisture vapor emission rate. Here's that 3-pound number that most flooring manufacturers recommend. Now, one thing you've got to keep in mind is that 4-inch thick slab was tested in a very controlled laboratory at 72 degrees Fahrenheit at 50% RH. That is not the real world. First of all, I don't know how many 4-inch slabs we work on a regular basis, but that curing of concrete basically starts when you close the building, turn on the HVAC, and create some sort of a negative drive to allow the moisture to come out of the concrete slab. It just basically wants to be neutral and happy, keep its humidity, inside of it until you start drying it out, and that's when we start getting into some problems. Water-cement ratio is one of the main drivers for concrete drying. Here are these water-cement ratios that are explained in that ACI document. Drying on one side, these are the number of days it's going to take to get to a 3-pound 1,000 square feet number. As you can see, the higher up you get with the water-to-cement ratio, the amount of days it's going to take a lot longer to dry. Exposed to vapor, which are like high humidity, exposed in contact with water, you see some of these things are frankly never going to cure. Which is something you need to keep in mind as well. Concrete does not really begin to cure until it's closed in. You create a drier environment inside, and that's when it's going to start losing its moisture vapor emission. Most concrete is going to be placed at this level, 0.4 to 0.5, but when it gets thicker to pour, the ready-mix truck has a tendency to pump more water into it. Those are the kinds of things that are going to jack this number up and extend the dry time on that. Obviously, the thickness of the slab also impacts the dry time. We talked about this 4-inch slab at a 0.4 water-to-cement ratio. If I take that slab to 6 inches, it's going to take twice as long to dry. 7 inches, it's 2.5. 10 inches, it's 3.5 times as long. So in this particular case, a 10-inch slab at 4.4 water-to-cement ratio. Remember, it took 92 days to get to that 3-pound number. It's now going to be almost a year to get to a level where you can install over it. Secondary exposure to water. Of course, we pour a concrete slab. You try to protect it from rain and water. But if it gets exposed to water, that drying cycle has to start over again. And I don't know how many pictures I've seen of open construction, whether it be residential or commercial, where it's not entirely closed on a concrete slab. It rains, the water soaks into the concrete. You've got to keep in mind that that's going to start that clock all over again and try to get it to dry. Obviously, my business is in the floor covering adhesive world. When you have wet concrete or wet anything, it's going to impact the performance of an adhesive. And we're talking about very engineered and performance-driven adhesives trying to hold a living material on the floor. So additional water or excess water does create some pretty significant impact on bond strength. Water-based adhesive being more impacted with that kind of a condition than solvent-based products, but it's something you need to keep in mind. Moisture sources in concrete are basically 3 main categories. The water of hydration. Concrete is not created without adding water to a cement matrix. That's considerably about 25% of the cement. But that kind of concrete is very difficult to place. So they add what's called water of convenience. And this is what's brought on the ready-mix truck in the big tank on the side. It's a known quantity. He'll add another 50 gallons, another 10 gallons of water to get it to be something easier to move, pump, or place. The other ones that these are both 2 well-defined numbers. We know how much water went in to make the cement. We know how much water was added to make it easier to place. But these are the mystery numbers, particularly the water coming up through concrete from underneath the slab. These are the ones that are a little bit of a mystery. From a flooring manufacturer standpoint, from an adhesive manufacturing standpoint, these do not bother me too much. This one is the thing that drives us all crazy. Moisture movement methods, capillary membranes. Concrete is porous. It may not look like it is, but it's filled with a lot of cracks and crevices. And you'll see an example is you take a straw and put it in water, in a cup of water, it will actually lift up a little bit in that straw. That's called capillary action. So you've got all these little tiny straws in cement. It's going to want to take that water or water vapor and move it right up the top. Humidity and temperature differential. This is a very important one. As I mentioned before, concrete does not really begin to lose its moisture until the atmosphere's humidity is dried. So this is when we start getting into problems with wood floor installations or any kind of installations per se with a fresh concrete slab. The building gets enclosed. We have a fast track requirement to bond flooring to that site. We're sticking things down and then they turn the HVAC on. It starts to dry out the air. All the water starts to escape out of the concrete slab and you wind up with bubbling problems in vinyl flooring, warping problems in wood flooring, etc. The alkali-silica reaction is a little bit more of a chemical deal. In a concrete matrix, they have silica or alkali globules that will actually act like a water pump. They are very salty. The water wants to go into them, require osmotic drive, and it's going to pump water out. Those are really bad things. Those are the kinds of, those types of reactions cause what you've seen when a vinyl floor, I think this is a very classic one, a vinyl floor in a gym floor where a guy cut it with a knife and a geyser of water came out. Those are typically driven by what's called an alkali silica reaction. It's part of the cement action going on. Again, this is an example of what's going on with an alkali silica reaction. These little modules will actually pull water through and drive it through the concrete slab. Preparing concrete for wood flooring, obviously you want to make sure it's smooth and flat. You can certainly hand grind for localized areas. There are specialized equipment for large areas, as you can see in this particular picture. You always want to make sure you're wearing proper protection, dust masks and respirators, because there is silica in a concrete, and as you grind it, we want to try to avoid inhalation of any grinding during that process. For repairing it, obviously, with light repairs, you can use polymer modified cement-based products. I would like to recommend for you that if you are using adhesives for the bonding of your wood flooring that are moisture controlling products, and many of us manufacturers do make those kinds of things, we'd recommend that you would use a exterior rated patching compound to do your remediation or patching. The reason being is you're using the adhesive to trap the moisture from getting into the wood, but if you're using a polymer modified patch underneath that, it can have a tendency to soften that patch, destroy it, and you wind up with a loose spot and a potential failure on your hand. We don't necessarily like gypsum wood floors under wood because of their humidity content and the fact that they're not quite strong enough in terms of their tensile strength to be able to take the strain of any kind of movement that a wood floor might experience in its normal life. Moderate repairs in big areas, self-leveling compounds are available to fix these. These require typically a primer of some sort. Manufacturers make all different kinds of these things. They're suitable for repairs up to 1 inch in depth and so on. They do require profiling or shot blasting prior to installation. Not all of them. There are certain levelers out in the market which are called shrinkage compensated that do not require shot blasting, so a typical primer shrinkage compensated leveler will work. Having a floor perfectly level for a wood floor installation is probably one of the most ideal situations for gluing wood floor. There's no dips, there's no divots, it lays in properly, the adhesive goes down nicely, and it makes a very solid wood floor. Highly recommended. Typical wood flooring can be installed in these things 24 hours, 36 hours later. It all kind of depends on how thick you apply them. If it's more than a half an inch of leveler to an inch of a leveler, I would extend that to 3 days to 4 days to get the rest of the moisture out. If it's less than a quarter of an inch for the most area, you can get on these things in 24 hours. Heavy repairs, say for example you're trying to match up 2 levels of a building. You had a sunken living room, you want to make it all flat. There are screed products, which are basically cement in a bag that allow you to use them in thick layers, up to 4 inches at one point. But the key factor here that I want to bring to your attention, if you're putting that much cement in a location to level it out, your water clock or your cure time to be able to install flooring on it is highly extended again to another 30 days. There's a lot of moisture in these things that does have to leave the system. So that does extend your clock out for 30 days. Not very many residential applications are going to use this. It may come into a commercial application on occasion, but I just want to let you know these things are available to use for that application. If you need to do moisture remediation, when you do your moisture testing or you're dealing with a flooring that may have failed because of moisture areas, there are a variety of different solutions to do that. Old school recommendations, I shouldn't call it old school, but it is kind of old school, is an asphaltic mastic under a roof felt paper or building paper is some of the NWFA recommendations to protect a wood floor from moisture. And that would be like a hot mop asphalt coating on the floor. And it was done historically many years ago, and that's probably the reason why water-based finishes were made for glue-down floors, because the solvent would go through and affect that asphaltic base, and you'd wind up with black lines between all the wood floor because it solvated it. So there it is around there. You'll occasionally see a glue down on the floor that was done where you'll see asphalt mastic holding it in place. Polyethylene sheet is another way to do it. Latex-based sealers. There are a variety of products on the marketplace today that can be applied over concrete that are ready to use, if you will, acrylic-based sealers. These do not necessarily have all the moisture protection characteristics that a two-component epoxy would be. This is an example of what you might see here. This is a very commercial product. However, it has its applications in residential. If, for example, I was a contractor and I was going to be installing a very exotic hardwood, Jakarta, Bobinga, those names, and it's a very expensive material, I would want to make sure that that floor was entirely protected from any kind of moisture whatsoever. I would highly recommend the installation of a two-component 100% epoxy barrier. Most of our one-component reactive urethanes will bond directly to that, and you'll have a perfect insulation protected from weather or from moisture for the life of the floor. There are also one-component urethane membranes or adhesives also available that can protect wood flooring from moisture vapor transmission through a concrete slab. So subfloor basics, again, the summary are they need to be clean, flat, smooth, and dry. Then the wood needs to arrive on the job site a minimum for 72 hours with the HVA system totally operational and building acclimated and stabilized. Very difficult to do sometimes in a residential application. Homeowner can't leave it open for 3 days, or you don't want to put in. This acclimation does not mean storing it in the garage. It means storing it in the location where it's actually supposed to be installed. So some techniques for installation of wood on concrete. I'll talk about two different methodologies. There are nail-down recommendations and glue-down recommendations. Again, a way to do this using nail-down methodology is to use what's called a sleeper system, where pressure-treated 2x4s are bonded to a concrete subfloor using either an asphaltic-based material or some solvent-based construction adhesive that's water-resistant. On 12-inch centers, a polyethylene sheet is draped over these sleepers, and the standard nail-down process is used to install the flooring. This does, however, add quite a little bit of height to the overall installation, so you're going to have to wind up cutting all the doors off 2.5 inches, depending upon the floor thickness and what's going on with that subfloor. But that is a possibility to deal with moisture vapor on or to install on concrete. Another traditional practice is to use a plywood underlay, where polyethylene sheets are draped over the concrete floor and overlapped at least by 4 to 6 inches. 3/4 inch CDX is spot nailed to concrete, which I never quite understand. You're poking holes through the membrane, but that's how it's done. All these boards, by the way, are kerf cutted in the back to make sure they lay flat on top of that. And the standard nail down process occurs on top of that. Typical build heights on that area, again, are 1 3/4 inches to 1 1/4 inches, depending upon the flooring type, 3/8 to 3/4, and so on. Now, when it comes to gluing adhesives to the wood floor, wood flooring to concrete, there are a variety of different choices. Solvent-based adhesives are still around, not as prevalent as they used to be. The old school chlorinated materials, which were probably, in my opinion, some of the best wood flooring adhesives ever known to man. If you ever met a guy that was a flooring installer that glued floor down with a chlorinated solvent, do not ever shake his hand. These guys look like the cartoon character from Popeye. Their grip was so, these things were very stiff and boardy and very difficult to move. Tremendous amount of strength to be able to move them. But grabbed very well, had great green strength, but due to the Montreal Protocol of 1981, they've basically been regulated out of existence, so they're not around. However, there are still some solvent-based, alcohol-based, resin-based adhesives available to use. They are restricted in many areas due to the air quality control measures, but they are still around. There are some water-based adhesives out there designed to do both engineered and solid wood flooring. The key factor to a water-based material is that it must have a very high solids content. You do not want much water involved in that installation so that that water could cause any kind of weird phenomenon occurring with the wood flooring. I've been in this business now for 28 years, and I've seen this whole thing develop. And I've lived through nightmare stores where we tried to do this with 70% solids material, and the whole floor cupped up like a deck of cards. It was not a good situation. There are some new technologies out available that we call cross-linking that are water-based materials, and they do work fairly well for the installation of both engineered and solid. There are urethane adhesives out here. They're one-component materials that react with the moisture in the subfloor, in the air, and in the wood. That's what causes them to cure. The wonderful chemical reactions. They're solvent-free, water-free, and work extremely well for bonding wood floors of all types, including bamboo, to concrete substrates. The latest technology that's been brought to the market are silane modified polymer adhesives. These are very similar to urethane materials, except of having an isocyanate reactive group, they have a silane functional group. They still react with moisture in the air. These do seem to clean up easier from the surface of a pre-finished hardwood flooring, as opposed to the urethanes, which really do like the urethane coating that's on top of those as well. The things that you need to be looking for performance requirements are bond strength. Obviously, wood is a very dynamic flooring material. Any changes in humidity is going to want to make it move or change dimensional stability. So we want to find adhesives that have bond strengths in excess of 120 to 180 psi to control that lifting phenomenon. Elongation is also a very important factor. This is a series, you know that's in that previous slide I showed you before. The exposure of moisture, any changes in humidity internal of wood is going to want to make it grow and shrink in length and width. Getting an adhesive that's got elongation of 75 to 150% to compensate for that is extremely important. Trowel ridge holdout is more of an application value, but you want to have an adhesive that wants the tendency to stand up after you trowel it rather than slump down after it goes down. Again, this is important to achieve proper contact with the adhesive. Most of us in the flooring manufacturing domain always suggest that you pull a board up every once in a while and check for adhesive transfer. Listen, I've done that before. It's a huge, giant mess. Just make sure the adhesive is sticking and standing up and make sure you have good contact. If it does not, this is where you get the hollow spots and you're back doing injections or repairs and all that kind of stuff. Adhesive trowel selection. You may wonder why is it that manufacturers of adhesives have so many different trowels available to glue things down. Many of you accuse me it's just a way to sell more glue. It is, but not always. But the reason why we have these trowels is to make sure that the glue line typically does not get above the tongue or above the groove as you're sliding these things together. In this particular case, using a 1/4-inch trowel to apply adhesive for a 3/8-inch wood, you're going to get all that wood that's going to get up on top of that tongue, and that's not a good situation for cleanliness or ease of installation. You want to make sure you use the right trowel for the right type of flooring that you're installing, for the proper bond and for installation ease. Direct glue to subfloor, again, the requirements are that they need to be flat, smooth, moisture vapor emissions need to be within tolerance. The total build heights are going to be roughly 1/8 of an inch. That's your glue line, plus the thickness of the flooring. These are the various types of adhesives available to do that kind of stuff. Urethane membrane systems. If you have to, I think I have another slide in here. There are 2-step processes still available in the market where a urethane membrane is applied first to the floor and you apply an adhesive on the top of it. These can typically go up to higher moisture vapor emission rates and RH levels. They do also add some sound dampening value, and the build heights are roughly 1/8 of an inch to the entire floor process as well. But these still are in existence and well. The latest trend in floor covering for wood flooring are multifunctional adhesives that are single products. They do provide bond, they provide moisture control, and they provide some sand reduction in a single step. The technique by which this is done is, quite frankly, to create a monolithic layer of adhesives underneath the wood flooring. Those monolithic layers block the transmission of water. They also add the resiliency for the sound dampening and bond extremely well. The moisture vapor emission rates that are available in the market today range from 15 to 25 pounds and up to 95% RH. These are basically your best insurance policy for bonding wood floor or bamboo to a concrete subfloor. They're the best solution to protect that investment. So how do you select the right method? You always take a look at what the flooring manufacturer says. Each box of flooring usually comes with an instruction sheet. Please read it. It's very helpful. I ask you to do the same thing on the flooring adhesives that we sell and manufacture. You want to look for performance requirements. What's the subfloor moisture requirements? What build height you have available to you, the cost to install, and the warranty. So those are the basic attributes of why you would select the right method and the right product and system for that. And with that, I'm going to transfer it over to my esteemed colleague, John Nava, who will talk a little bit about what's going on with wood floor substrates. John?
Good afternoon. Has everyone been walking the floor surfaces? Isn't it nice to sit down for a little bit? Oh man, that short little rest I had was great. I'm going to be covering pre-site conditions over wood substrate. We're going to talk about some of the industry requirements and recognize what tolerances mean, why they're important, and try to implement some new ideas for you to keep the profits instead of losing them. How many of you are out there bidding work? Probably almost every one of us, right? How do you bid floor prep? That's a tough one, isn't it? That's a gamble. It's kind of like coming to Las Vegas. It's a roll of the dice. Sometimes you win, sometimes you lose, right? Because a lot of these folks want their bids and they want a hard number, right? So give me a hard number. So you think, okay, I'll add this much in for floor prep and hopefully it'll be okay. Your installer gets on the job site and says, you know what? This is going to take 2 days to get this floor ready. And you only figured maybe half a day. Are you going to go after the end user for more money? You try, right? We try to keep that open-end contract and try to get a little bit more money. Or sometimes we end up eating it. All right? Now, here's a scenario I see. And I'm hoping that there's some balance here. Am I speaking too loud? Okay. All right. I'm kind of a loud speaker for a small guy. So you have the installer doing the floor prep. Retailer hasn't got that much money into it. You have two choices. Do you pay the installer more money? Or do you just tell the installer, okay, do just the minimal amount to get us by? And if the installer says, you know what, it's not the right way, you approach the end user. The end user says, you know what, you gave me a hard number here. That's the number I'm going with. You better stick with it. So, guess what? Somebody's going to come up short on that floor prep, right? Is it the retailer, the salesperson that takes it in the shorts, or is it the installer? All right? This is a scenario I hate. Because I come from the installation side of the industry. When a salesperson tells you, you know what, take care of it here and I'll take care of you on the next job. How many of you installers have heard that? Okay? For you retailers in the group, do you see, do we get taken care of on the next job? Sometimes, sometimes not. But that's where some of that frustration level is. You know what, let's work together. All right, let's bring the installation side of the industry together with the sales side. Look, salespeople and estimators, if you have a question on floor prep, don't assume. If you haven't ever done floor prep, don't assume, all right? Get your installers involved. Get them involved with, hey, what does it take to actually do floor prep on a job, all right? So we're going to go through some of the scenarios here and show you what's out there. And hopefully, as a retailer, as an installer, as an industry, we can come together and do a better job and all make money. Isn't that a novel idea? All right? Okay, so here we go. We have different types of construction, right? Believe it or not, most of the time we go to the job, we never see what's underneath on, as far as the joist. All we see is the subfloor. We go out there, we install our product, whether it's wood, bamboo, laminate, we install over it. All right? We see that it looks clean, looks pretty flat, we're good to go. There's a lot of components to a building structure that hopefully you will get to understand after this session here. You have open joist construction here. Why do they use open joists? Couple of different reasons. Cost, right? They're not using as much lumber, and also they can take their heating ducts and their electrical work right through, rather than having to drop down, with the sheetrock and then create a box to run all the duct work in that. They can actually run it right through here, so it's a nice, clean, flat ceiling. They don't have to worry about any drop downs or anything there. But what that does to our side of the industry, this is a little weaker subfloor system. Out of all the subfloor systems, this is the weakest one. All right? Keeping it at 16 on center is pretty good. But now you're seeing so much more construction going to 19.2 and 24 that starts, you start getting that span rating a little bit wide there, and we're going to talk about that next few slides here. Next one is solid board. This is a good old-fashioned, this is how they, this is old school way of doing things. You still see it nowadays. It's still there. This is one of the better systems that are out there. This is one of the better systems. Here you see they're kind of drilling through for their electrical, but there's no way they can get their ductwork through. So they would have to drop down and build out for their ductwork. But solid board joists are one of the most stable and solid type of floors out there as far as stiffness. You're coming out, you're seeing all this new technology. You're seeing I-joists out there, typically a 2x3 with OSB panels in between. They're very stiff, they're very rigid. What are the advantages here? Once again, you're getting a stiff joist, plus you're still controlling the cost. You're still able to control cost because you're using OSB as a product there, and instead of going to that solid board, which is a little bit more money, this gives you a little bit more of an advantage as far as pricing, plus it gives you your stiffness. So this is still an excellent product right here. So between the I-joist and the solid board, you've got a pretty good system. Those of you who are out there going out to measure and estimate, look, if you have an opportunity, look up underneath. See what type of joist systems there are. Are they 16 on center? Are they 19, 24? What type? Is it a solid board? Is it an I-joist? Take a look and see what you've got, because it's going to help you and your installer. Bounce on the floor if you have a chance. See what kind of movement's on the floor there. All right? Now, the industry says, when we install our flooring product, if it's a nail down, to run it which way to our joist? Perpendicular. Why? Because if we run it with the joist, the potential for this to happen, because we're having that deflection in between the joists, there's a potential for movement there, and you start to get some buckling, some gaps. Well, what do you do when you have multi-directional? Here's the joist running this way, and all of a sudden, the floor is running this way, and yet up on top, it's all wide open. So as an installer, as an estimator, which way do we run the floor? Actually, you know what? That's not a bad idea. Diagonal is one way. The gentleman here said that diagonal. That is one option. All right? If I'm looking at this job right here, I see the majority of it running this direction, and I see a short section of this. It looks like right here is not too big of an area. You've got to discuss that with your end user. But for me to look at this, if they don't like the diagonal look, they say, no, we really don't want diagonal. I would probably go this direction here for the floor. And then, you know what, and I'd be up front with my homeowner. I'd say, you may notice something right here. Get them involved with that decision. And right up front, get them involved with that decision. Because if you as an estimator, you as an installer, just choose the direction that you want to install because you're the professional, and 6 months down the road, you start seeing a few gaps every 19 inches, 19.2, guess what? An inspector goes out there to look at the job, and they see that you ran the job parallel to the joist. Who owns that job? The installer. Yeah, the installer. All right, so estimators, installers, make sure you discuss this with your end user, your homeowner. This is not, we didn't build this house. Yet we're taking once we put that wood in, we took responsibility of that floor, right? We own that floor. And if there's issues down the road with it, they could come back to bite you. Okay? You may have put part of the floor in right, but if you did, but you may have put part of that floor in wrong. But are they going to just have you replace part of the floor? No. Chances are you're going to be replacing that entire floor. Okay? Now, are there things that we can do? Let's say, oh, come on, slow down, John. Let's say, that they do want to run it. We're going to run it perpendicular here. We can take a look up underneath here and see if we can put any cross members in there to stiffen up the floor a little bit. So there's some things we can do, or you can recommend that a general contractor or someone do to stiffen up that floor, to minimize any potential issues down the road. All right? This one gets me. This is in the APA. All right, this is for general building contractors. They're telling these general building contractors, we have advanced framing. Let's think about this. Let's save some cost for the builder. Let's go to 24-inch on center. All right? Let's go to 24-inch on center because it'll lower our material and labor costs than conventionally framed structures. We're not thinking about the flooring guys here. We're thinking about the general contractor's pocketbook, not ours, right? It's going to hurt our pocketbook. So here they've said, specify engineered floor joists, such as I-joists, which is smart. That's smart. Structural composite lumber or glue laminate 24 inches on center. Maximize your member stands between supports. So in here it says floor framing is generally subject to home design foundation requirements, yada yada, but substantial resource and cost saving can still be utilized with the principles advanced framing. I don't like that. I really don't care for that. And then when you come down here, when installing floor sheathing, that's your subfloor, keep in mind that many of today's home buyers expect stiffer, more solid feeling floors. Consider using thicker panels. Consider. It doesn't say you must use, it says consider it. Okay, I'll consider it. Nah. Just why? It costs more money. Why would I go? I considered it. You know what? It wasn't a consideration. I don't like that. All right, because it opens us up as installers, retailers. It gives us too much liability on our end. We install a floor. There's problems with it. You know what? You have. It's a big fight. All right. So NAHB approached the National Wood Flooring Association with this. All right. They said, "Look, guys, we've run all the tests. We know that this system will work. We meet all the flatness requirements. We meet all the requirements for movement. Why can't you guys just acknowledge it?" You know what? When they measure deflection, when they talk about L over 360 in that, they're measuring that entire floor for movement. And L over 360 gives you about a half inch and 15 feet. Well, the problem is when you go 24-inch on center, it's in between the joists that we're concerned about. See, they're not taking that into consideration as builders, but that's where we come in, both on the tile side of the industry and the wood side of the industry. So that's why we came up, the NWFA said, no, we're not going to do that. We're going to stick by our guns. So we're going to say 16-inch on center, 5/8 CDX, and if it's OSB, we're still going to require 3/4-inch OSB on 16 on center. 19.2 on center, 3/4-inch or 23/32 CD plywood, 23/32 OSB. Can I go 24 inches? Yeah, I can go 24 inches, but make it 7/8 CDX and 1-inch OSB. That's where a lot of builders will take that shortcut. They'll just go that 3/4, which actually isn't 3/4, right? At 23/32. Can they go a double layer plywood? Yeah, they can. So here's your double layer. First layer 3/4 CDX, second layer half ply, but they're not doing that. See, they're not doing that. Solid board subfloor. Have you seen those boards, the older homes that ran at a 45-degree angle? That's what they're referring to as a solid board subfloor. It's a 1x6 installed 45-degree angle, and there they tell you, check with the manufacturer to determine if that floor is suitable. Flooring is suitable for that subfloor. All right. Pier and beam. Some parts of the country. Anybody in a part of the country that has pier and beam construction? Where are you from? California. California has pier and beam. What part of California?
Old Sacramento.
Old Sacramento. Okay. All right. Yeah, there is some movement there in there because you got, what is that river? Delta. Yeah, that's okay. So pier and beam. What pier and beams do? They allow the surrounding soil to rise and sink with minimal effect to the house. Right? It's kind of like having an island and just letting it, do whatever it wants. And expansive soils that contract, expand a lot. Pier and beam construction is well suited for those type of areas. So here's a pier and beam. Here's your footing. Here's your pier. There's your beam. joist, subfloor, and then your flooring. So there's a kind of a look-see of what that is like right there. Now, are there problems with some of the pier and beams? Whoops, wrong picture. Okay, it was supposed to be followed right there. We'll come to it, I hope. Is that a problem? Do we see this? Well, that as an install. Okay, remember, this is just in the framing stage. Do we see this at the, when we're ready to install? That's why it's important as an estimator, installer, if you can, to walk through the job. But by this time, this is an easy fix though. Okay, real simple. All you got to do is boom everything over into the basement. Okay, that's a simple fix. Or let's just let it dry because the wood will absorb it, right? So don't worry about it. As you're estimating, you're installing, walk in, especially with OSB. You can see it on plywood too. Look for the water spots. All right. Usually you can't even see the floor because there's so much garbage on the floor. But at least try to see if there's any moisture intrusion that occurred during the construction phases. The problem here is you've got a product that's probably already around 16 to 18%. That's what your subfloor comes in. Typically, they don't dry it down to 6 to 9% like hardwood flooring or bamboo and that. Your lumber is typically at 16 to 18%. They dump it outside, right? And then they start their building. When this gets wet, it's already probably still at 16 to 18. It's probably at saturation point. They're putting the framework around it, enclosing that. How long is it going to take for that moisture to evaporate out of that system? It could be longer than 1 year. You may be putting your flooring over a wet subfloor. And guess what? 2 months down the road, you're back there with all kinds of issues, and that happens all the time because installers aren't checking moisture content in subfloors. All right? This is why you need to, because you don't know what happened prior to you being there. All right. I wonder if I copied some of my slides over. We did a copy and paste a little bit ago, and I'm not seeing some of my pier and beam that were supposed to be there. Oh well. Subfloor stored outside. I was up in Park City, Utah, just I think before Christmas. This is the subfloor that they're using. It's a big condominium project up there. I'm being brought in as a consultant to make sure everything's good with site conditions. I'm helping them pick their product to make sure it's suitable for that environment. So this is the first walkthrough of the construction project that I'm getting involved with. I see the subfloor stored outside. Okay, all right, well, at least it's covered a little bit, right? So we're walking through inside the building. Remember, there's hardwood going in here, okay? Is that a problem? Yeah, all right. When you're out there looking at your jobs, if you have an opportunity, if you're bidding a big project, check in on the project to see how it's going along. If you're an estimator salesperson or you're the installer that's going to be on that job, make sure you do some follow-up site inspections prior to you being there, just to see how the building's going, kind of see what's going on there, because that's a huge red flag right there. All right? Huge red flag. Because, yeah, there's hardwood going all through this area, but there's snow covering it. Yeah, it is an issue. All right? And that's what happens. After it all starts to dry out and evaporate, you get the joint swelling. If you see joint swelling, that means that floor got wet. Installers, estimators, think. This floor got wet. We need to address this. We need to make sure we understand what the moisture content is, and we need to, now we have to address all this here. So they've nailed this entire floor down. They typically nail it because they're not going to take the time to screw it down. We will, but most of your framers are going to just get their pneumatic nailers and boom, 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 right? Do they spend time to screw in the floor? Typically not, right? So what does that mean? I've got to come in and sand that down. Is that going to take time? Yeah. That's called floor prep. Okay? If you don't bid for it, here we go. Who's paying for this? Who is paying me as an installer to come in and sand those floors? Is it part of my job? How many of you think it's part of of an installer's job to sand floors? Probably don't want to raise your hand because if you do, you're going to get beat up. But I wouldn't do that though. That's why it's so important to look at your subfloors prior to having that installer, go out there. Because you don't want to lose. There's half a day, at least half a day, right there. Okay? And now you're telling your installer, you got to be done today because you got another job we have to be on tomorrow. Is that fair to the installer to have to work till 10 o'clock that night just to accommodate, to get to the next job the next day? You see the scenarios, how they all play out? With one simple, little thing like that, joint swelling. All right? So retailers, estimators, installers, once again, let's work together. Try to, let's all make some money here. But that is considered floor prep right there. Okay? Should be addressed immediately. So get it on to the builder. Yes.
How long do you think a 16 to 18% of 1% content subfloor would take to hit the order material, let's say 60% design material with a couple layers of craft paper?
Okay. His question was, how long would it take a subfloor that's at 16 to 18% to kind of dry down with a Brazilian cherry? Let's say we're going to put with a wood product, wood bamboo, and we're going to put 2 layers of craft paper. Okay. You know what? That's a good question because that happens all the time. You know what? It's a little wet. Let's just put some craft paper on. Well, it's a little wet. Let's put 2 layers. That way you've got double the protection. That happens a lot. The problem with that is that moisture is still going to work its way through. Okay? And there's still going to be an imbalance. Once you put that flooring on, and there's moisture at 16 to 18%, and if you're down at 8%, let's say 8% with your wood, guess what? There's a huge difference, and we're going to talk about what those numbers should be. I think I got it in here. I hope we copied it. There's a huge difference. Yeah, huge difference. That moisture is still going to drive through. Okay, and the minute the HVAC system gets kicked on is when all that reaction is going to start to occur, because that subfloor is going to start to dry, and that moisture wants to evacuate immediately. Okay. Yes. Hold on one second, I can't hear you. Excuse me. His comment is, once OSB gets wet, it has no holding power with the fasteners. Can it be compromised a little bit? Yeah, it can be. Now, if you talk to someone from the APA, though, they will tell you, you know what? Moisture doesn't, no, it's the same thing as plywood. I think there's some politics involved there, personally, but yeah, it can compromise. It can compromise the holding strength of the fasteners. I'm in agreement with you there. I personally don't like to go over OSB personally with a nail down, but that's the way it is. You're seeing those type of subfloors come into the market more and more. All right, board subfloors. Can we? Oh.
You didn't answer the question. The question was.
Sorry, I got sidetracked. I didn't answer his question.
How long do you think it would take for that to dress?
Okay, it depends. It's a time thing. It's a time thing.
You're an expert.
Yeah, it depends on all the ambient conditions. So if the HVAC system's on, it could take 2 months. It could take a week. Who knows? It's a time factor. Okay, you don't know. Here's a scenario. It happened to my job. New home, brand new home. We monitor every job we go into. I think I got time to answer. We monitor every single job we go into. We check the conditions, site conditions, okay? We had all our wood floor down. We had it sanded. It was ready for stain and finish. The day that we were going to come in to stain and finish, I was pulling in, my trailer got broken into. Okay? We walk in, or we drove into the backyard, we see my trailer doors open. $15,000 worth of tools stolen. Killed me. Yeah, we walk into the house. These guys stole the customer's microwave, dishwasher, plumbing fixtures, and electrical fixtures. When they disconnect, everything was connected up. When they disconnected the dishwasher, they left the hose right there. The marble guy's working in the house, okay? So he's running the water in the sink for his water to polish the marble countertops. Water's draining out onto our floor the day we're supposed to put our finish on. It took 2 months. It took 2 months. Because they said, oh my gosh, what are we going to do? I said, I can either replace it or you can just let it dry. How long is it going to take to dry? I couldn't tell you. It took 2 months. But they were willing to wait. I said, what did we dry to? We dried down to, I think it was like 7%. So, in our area. So that's where, because it matched the other area that was unaffected at 7%. So we let it, but it took 2 months. Okay, with air movers. All right, we turn the air movers on, turn them off. Let the wood kind of acclimate a little bit. Turn the air movers on, turn them off. Okay, so it took 2 months. So it's not, well, can you get it dry in a week? No, it's a time factor. Okay, that's what it is. It's time. That's all it is. All right, now did I answer it? I can't answer it. I can't answer it. Yeah, I can't answer it. Board subfloors. Can we install over this floor? Yeah, just, depending on the manufacturer, if it's an engineered product. Solid 3/4 inch, yeah, we could probably go over that type of floor. All right, so here you have OSB meeting 4 corners. All right? When we install OSB as a subfloor, you're supposed to stagger your joints, right? So what do you do when you come to this situation? Walk off the job? Yeah, cross your fingers? Yeah, that's a tough one because we weren't responsible. Unless you're a general contractor, you can't tear into that subfloor. Okay? Because now you're dealing with structural. So you need to either get the builder or someone to address that and, have them come in and get those staggered. Or else, guess what? You take the responsibility. Yes? Could you go to 3/8? You could go 1/2 inch. You could go 1/2 inch. Yeah. But then, you got all your doors, everything else comes into factor. Your height, okay? That plays a factor there. So take a look at that. If you want to know what to look for as you're, reading your, looking at your subfloors and that, look up underneath your joists. This will tell you a lot. When you see this 3216, you think, what the heck is that? It's your span rating. The span rating is for both roof sheathing and floor. That 32 is your roof number. The 16 is your floor number. Okay? That tells you the thickness. Size for spacing. What is that? Industry says you need to allow 1/8 of an inch around each panel of 4x8 sheathing. Okay? 1/8 of an inch. Why? Because subfloors expand and contract too, not only your wood floors. So if you don't have a size for spacing subfloor and they've got it tight, guess what? Your issue could be the subfloor and not your actual flooring. When it says size for spacing, they've allowed for that 1/8 inch gap around the entire panel. Okay, so that's a good thing to see. All right, then it gets you all your other, the mill numbers. And a lot of this is, more for their information. It meets certain minimum requirements. But the biggest thing you got to look at is, your thickness. Make sure it's got the exposure 1. Your size for spacing. What if you what now? What if it's already been drywalled underneath? You hope maybe they put one of the panels upside down so you can read it from the face. Yeah, that's a tough one. You can ask the questions and try to look for a heater vent or something, get somewhat of an idea, but yeah, that's a tough one. Most builders have to follow certain building code requirements, so they're going to typically, you don't see, this is where you see kind of the shortcuts are some of the remodeler guys that, or the homeowner that tries to do their own. So that's where you kind of got to be careful. Okay? So there's a grade stamp right there. You just check it out and see what it's, see what it says there. This is designed for up to 24-inch spacing. Okay? All right. Floor flatness. 1/2 inch and 2 feet, we should be good, right? Just a slight slope. Nothing too serious. All right. So what are the requirements? Now this is interesting. This is in the NWFA, National Wood Flooring Association, Chapter 4, Wood Subfloor Guidelines. This is the part that I want you to see. So, if peaks and valleys in the subfloor exceed the tolerances specified above, sand down the high spots and fill the low spots with a leveling compound or other material approved for use under wood flooring. However, it is the builder's or general contractor's responsibility to provide the wood flooring contractor with a subfloor that is within the tolerances listed above. You know how we talked about floor prep? Right here. It's in the NAHB and the NWFA guidelines. Okay? Refer to this. Use it. You know, refer to industry guidelines to help you, try to get more money. Okay? All right. And, I don't think all are. Jeff has Microsoft. I have Mac. And I don't think they love each other. All right. Okay. Oh, there we go. Never mind. They're okay. Concrete substrates. Jeff talked about that. 1/8 inch and 6 feet. 3/16 and 10 feet. Here's where we come into the wood. Wood substrates, 1/4 inch and 10 feet. 3/16 and 6 feet with mechanical fasteners. That's your staples, your cleats. Okay. For glue down installations and installations using mechanical fasteners of less than 1.5 inches, subfloor should be flat to within 3/16 in 10 feet or 1/8 inch and 6 foot radius. Manufacturer requirements always supersede the industry. Okay, keep that in mind. And most floors not to exceed 1 inch and 6 feet of slope. Okay. Those of you who are those Breaking Bad junkies, I never saw the show. Excuse me. It's extremely dry here, isn't it, in Vegas? Any of you watch Breaking Bad? See, I never saw it. But I was looking for crawl space, and this is what popped up. I thought, that's pretty good. Story about a drug dealer or something. Everybody said it was a great show, or great, series. So here we have a crawl space. Excuse me. Any concerns? What do you see? Okay. And now the NWFA and their installation guidelines say, you should have a 6 to 8 mil black poly, draped up the walls, stem walls, overlapped. But a lot of building codes, local ordinances don't require that. A lot of areas in the country don't require that you put any polyethylene sheeting down under a crawl space, yet the NWFA guidelines still state that. Inspectors use that against installers. There was no black polyethylene sheeting placed under, and here, look at NWFA guidelines, okay? You got to be careful with that, guys. Those of you who are installers, estimators, you probably need to address this with your homeowners, okay? If they're not going to put that in there, and it's not a required building code in your area, you better put that into your contract, all right? Customer chose not to place black polyethylene sheeting in crawl space because it's going to protect you, because you know what? If you don't address it and you install and the inspector comes out there, they're going to go by the industry guidelines. And NWFA industry guidelines state that you should have black polyethylene sheeting underneath the crawl space. Okay? 18 inches from ground to the bottom of the subfloor. All right, yes?
A lot of homes in Southern California do not have a like this much.
He's saying a lot of homes in where? In California? Don't have the 18 inches? Yeah, well, okay. So, is that the installer's fault? Is it the installer's responsibility to dig out the crawl space? All right, so you installers, you retailer, salespeople, address it at point of purchase, okay? Not after the claim's coming in, point of purchase, all right? So here you have, what do you see right there? White stuff. It's alkali. Is that an indication of moisture? Yeah, it is, all right? What do you see on the ground? Nothing, right? There's nothing there. There's no polyethylene sheet. Is this a potential for moisture? Yeah, you see it already going up the foundation wall. What do you see there? The vents are all blocked off. There is no circulation in that crawl space. So you have this is a potential for a failure right here. Okay? Without even putting a piece of bamboo, piece of hardwood, piece of laminate down, you know this job's a potential for failure. Okay? So find out about it before instead of after. Save yourself some bucks. All right? Okay. Yeah. When you see water in a crawl space, is that a red flag? I think so. Yeah. If you see structures like this, is that a problem? Is that a red flag? Yes, it is. If you don't check these areas, who's responsible? You are. Yeah. Do we like to get in crawl spaces? Are you kidding me? No way. Take a flashlight with you. All right? Take a flashlight and camera, just shine the light, take a picture. Then, you know, everybody's got, almost everyone nowadays has camera phones, right? So you can check it instantly and determine what's going on before you install that job. This and this are both going to be failures. You know that, right? Because there's just too much movement, too much water. Crawl space venting. You're seeing more and more of this happening as the industry's getting educated. This is a good way to go with some of those areas in, you know, high humidity areas that have crawl spaces. Control some of that. I have an installer inspector that calls me once a week from, I think he's from North Carolina, South Carolina. He said, John, same thing happened. I said, you know what? Use the crawl space venting. It's helped save them some money because they're starting to recommend this. He said the number of claims that they're getting for cupping in that has definitely gone down since they started recommending this. So there are ways to vent. All right. So what are proper conditions? 6 to 8 mil black polyethylene sheeting, overlap 6 to 8 inches in tape, minimum 6 inches up the stem wall, perimeter venting 1.5 square feet per 100 square feet of crawl space. Local building codes supersede. 18-inch clearance soil to underside of joists. Okay? All right. So here's a gypsum pour over wood. What are the problems with that? Typically it's breakout of gypsum, right? Okay, so here's the scenario. 5th floor condominium with gypsum-based pour that is fractured. What do? Do we move it and install new plywood so we don't have to deal with it? It's going to be, we'll say it's going to be a glue down. Would that be the best way to go? Any thoughts? Who says yes? Okay. Remove damage. Okay, I'm going to come back to that. Remove damaged areas only and replace with plywood. You know, just the damaged area with plywood? No. Re-pour new gypsum in damaged areas? No. Self-level over the top of gypsum subfloor? Yeah. And if leveler, what type? A cementitious? Over a gypsum? Interesting. Interesting. Okay. Remove and install new plywood. I'm involved with the suit right now that they did that. The installation company came in, put down, they tore out the gypsum because it was just broken up. Older building, tore it out, put new plywood down. Put the wood floor, it looks gorgeous, okay? The owner below complained about the noise. So they brought in a forensic engineer to determine what's going on with this, what's going on with the system there. They had us come in. We had to remove a section of the floor, a piece of the wood flooring, and underneath that wood flooring was plywood. So we drilled a little further, and they found out that it was plywood, and that's it. And then the wood floor. Guess what? They compromised that whole entire system. They compromised the fire codes, the condominium codes. They're having to replace the whole project, that whole condominium now, because they went in with plywood instead of a some sort of sound product, which gypsum is. It's not the plywood was not fire rated, which gypsum is. Okay, so to remove and install new plywood, before you do that, you better make sure about all the requirements of that condominium or whoever, whatever requirements that they have in that building. All right. Remove the damaged area, same thing. With plywood, you don't want to do that. Re-pour new gypsum in damaged area, that would be the ideal thing. But sometimes you can't, if you're on the 5th floor, it's tough once the structure is done, it's hard to get a pumper up in there. Chances are you won't. In fact, in this particular project, we can't. Self-leveler over top of gypsum subfloor? Yes, you can do that, but you better make sure the self-leveler is compatible with gypsum. Remember, Portland-based products, gypsum-based products are two different things. Portland-based typically shrinks, gypsum expands, right? So you get those two, there can be a chemical reaction. Okay? All right, and so you've got to understand what leveler to use. And if you're going to use a gypsum-based self-leveler, it doesn't act the same way as a cementitious or Portland-based self-leveler. Those typically, the Portland-based typically dry quick, within 1 or 2 days. Gypsum-based could take you 3, 4, 5, 6 days. Okay? They're totally different, and you have to understand which each one does. All right. Excuse me. To give you an idea of what water can do, I use this. I like this because it's a good visual. It's 2 by 4 by 12. All right. It's, what is it? 18 pounds, 17 pounds. Here's another 2 by 4 by 12, exact same dimensions, 30 pounds. What's the difference? Can you see it? You can't see it, but you can feel it when you lift them up, right? It's what? No, this came off the same load, exact same load. Okay? There wasn't. Yeah, this is one of our NWFA classes we were doing. I'm like, whoa, So I thought this would be a good opportunity to measure this out. So, dimensionally the same. Water is the biggest factor. That's why you can't just walk in and assume things, right? If you don't own, is that a new word? If you don't own a moisture meter, I highly recommend that you get one. All right, as an installer, this is as important as a hammer. All right, as an estimator, same thing. It's as important as your tape measure. Okay, you need to understand what's going on with the structures, whether it's concrete, whether it's wood. We as an industry need to get better at what we're doing. All right, we need to get better at what we're doing. All right, here's the NWFA and NAHB, part 2 of the guidelines here. It says, let's see, the NAHB Model Green Home Building Guidelines. This is for general contractors. Section 5.3.8. Check, remember, once again, this is for the general contractors. Check moisture content of wood flooring before enclosing on both sides. It's not the flooring. It's not the flooring. This is not for the flooring guys. This is for the general contractors. Ensure moisture content of subfloor substrate meets the appropriate industry standard for the flooring material to be installed. They have an obligation to provide us with a good floor. All right? But the problem is, if we don't do our due diligence in checking, guess who's responsible? We are, right? All right. For solid strip, there should be no more than 4% difference, moisture content between the subfloor and the wood flooring. For wide width, 3 inches or wider, there should be no more than 2% in moisture content. All right? Now, bamboo's the tricky one. Okay? The industry, moisture meter manufacturers out there, they're having a difficult time wrapping their hands around moisture content of bamboo flooring right now. So as an installer, be careful. As a retailer, estimator, we're still in the dark a little bit here because the strand woven bamboos, the bamboos, it's not wood. So they're trying to calibrate their meters to read grass. Okay? Some of the meters out there, the manufacturers are working on specific manufacturers because you can't just take bamboo and generalize it. They're having to take each manufacturer and getting their products to see what numbers work with that. All right? So as an inspector, don't assume your meter is just going to, just because your meter reads on bamboo or something, don't assume that you're getting an accurate reading. All right? Don't assume that. With bamboo, we're up in the air. With laminate, you can't get a decent meter reading with laminate either. It's just, it's difficult. You have a lot of adhesives in there, and typically the cores, MDF. So it's difficult to even get a reading on laminate, even though you may see some moisture meter manufacturers state, for laminate flooring use this. It's still subjective, all right? Allowable moisture content, typically for wood subfloors, most manufacturers recommend that those no more than 12 to 14% maximum, okay? And that's more for your floating floors. All right, make sure all your wet trays are finished prior to going in, all right? Because what's that going to do to the relative humidity of the home? It's going to jack it up, right? If you're taking your product into Acclimate and they're doing wet work in there, what's your product? Acclimation. Well, I acclimate for 1 week. So they're painting and doing sheetrock for 1 week. Guess what that just did to the wood? It got acclimated to the higher RH. So you're thinking it's at 1 week, I'm good to go. So you're putting in a product that actually went up in moisture content. You install it, it dries out, and now you got issues. All right? That's why you got to make sure all your wet work is done and make sure the product actually is acclimated to site and take moisture measurements.
I should probably know this, but is there a difference between the solid wood or engineered?
Is there a difference between solid wood and engineered for?
For that moisture content between subfloor and flooring?
Okay, so the question is there a difference between solid and engineered for moisture content between subfloor?
Right, the 2%.
Here's what you look at, okay? And this is, I mentioned this on Problems, Causes, and Cures on Monday. You have industry, your manufacturer guidelines say, acclimate 48 to 72 hours. Okay? That's fine. About 4 paragraphs down, it tells you site conditions must be maintained at 30 to 50, 55% relative humidity, 60 to 85 degrees Fahrenheit. But it's not up here. It just says acclimate for 48 to 72 hours. Well, I may not have 30 to 55%. I may have 20%, especially in Utah or Las Vegas right now. Okay? I may have 20. I acclimated it. But you know what? Down here it says it has to be 30 to 55%, 60 to 85 degrees. Guess what? They need, I told them this. I'd like to see manufacturers put this information with this information so an installer, a retailer understands that, yeah, acclimation is not just about 48 to 72 hours. There's something else, you got to add, you got to finish the sentence or finish the paragraph. Okay? That's the part that I'm having some difficulty with. Okay? Because we talked about normal living conditions. I had an igloo on one, and then I had, living out on Paradise Island, with a hut. So, yeah, there's differences in normal living conditions. Look at your exteriors also, all right? If you see, make sure drainage is away, not into the home. All right, that's one thing you got to look at. So when we're working out there as an installer, estimator, retailer, look at your outdoor environment because that's going to affect what's happening inside that home too. Okay? Cause and effect. All right. Hey, perfect timing.
Yeah, good job, John.
We actually made it. Any questions? Yes.
When you bring, I've got some on the job site right now. You bring all that wood into the house. I check the conditions. I have a hygrometer out there. Do you have to open those boxes? I know they say no, but does it really take all that moisture out of the wood? Does it acclimate without opening the boxes?
His question was, it says that he's been acclimating it on site, and it says keep it in the boxes, and he's wondering, well, do I really need to keep it in the boxes? If the manufacturer says yes, yes. Because what they've done, and this is where you got to be careful now. They've acclimated that box to put pretty much the industry is looking at. Typically it's 6 to 9%, right? Okay, now you've acclimated it for a week. You need to make sure that wood content, like the good way to do is check the subfloor. If that subfloor is within 2% of that engineered product, you're probably good to go. People think engineered is so much more dimensionally stable than solid. I go out on more engineered claims than I do on solid. With shear, delamination, checking, gaps, I go on probably 10 to maybe 1 solid. Because people think it's just so much more stable. No, it's not that much more stable. It just means it can go, it can be a little bit more stable because you can put it below grade, but it still has to have those minimum 30 to 50%. All right, so if you're in your dry zone right now, right? Where are you from? Ohio. You're in freezing zone right now. So your numbers are probably going to be pretty low as far as your relative humidity, because the heaters are kicking on like crazy right now because it's so cold. I bet if you went to check your hygrometer, those numbers are dropping if they got heat there, if it's controlled. You're probably down to 15% right now, or you may be even less, because you guys are in like teens or something. So right now your wood is 6 to 9%. Your wood is probably going to be a little higher moisture content than your actual your site conditions are. Would you be okay? Yeah, you might be. You have to know your region. You have to know your region. So when they say acclimate to site, once again, they need to finish that sentence. When I acclimate to my site in Utah, in the middle of summer, my wood came in on a project at 6%. All right? It was about 9 or 10% at that time because it was raining. Did I let it acclimate to that 9, 10? I put my wood in. Right there, I put my wood in with the lower numbers. You know why? Because right now, our dry season's here. So I know my wood floor is not going to shrink up because I put it at my low side. All right? I know what my floor is going to do in my area. So I know, do I have to let it acclimate for a week? No. If my numbers are low or whatever it is at the time, and I know I'm going into a wet season or dry season, I'm taking into consideration where I need to be in my part of the country. And that's why when they say acclimate to site conditions, know what your site conditions are. If you're putting in product in a humid environment, let's say you're in Ohio, because it gets humid there, and you're going in at 12%, and your winter time comes, and all of a sudden your product's dropping down to 6%, guess what? You're guaranteed gaps. It's going to shrink. So if I'm taking a job site and my wood's already at 6% on the low side, I'm not going to let it acclimate up to 12%. I'm going to put it in. I'm going to put it in right there and then. Okay?
This question might be for Jeff. If I'm in South Florida, you can solid 3/4 inches, typical scenarios with that 3/4 inch wood tap on the concrete or solar on top of that 3/4 inch. But I see there's membrane systems and the epoxy sealers also. Would that suffice to substitute the 3/4 inch? Because generally, I don't really see jobs that are doing that with the membranes.
The question is whether or not an epoxy.
Can you substitute the membrane system with the 3/4 inch plywood?
The question is whether or not an epoxy membrane could replace a 3/4 inch ply as a base for a nail. For moisture protection, yes. If you're going to direct glue those down, yes, you could do that. I mean, an epoxy membrane or even a urethane system will go directly on a concrete floor, provide ultimate moisture protection, direct bond, a 3/4 inch solid to concrete. Yes.
You say you can put that over concrete just with that epoxy sealer?
You can put an epoxy coating directly over concrete. It'll cure up in about a day, and then you can go back with your urethanes directly on top of that. Yes.
And remember, that's manufacturer. You better follow the manufacturer's guidelines for solid, okay? Because the industry, as far as NWFA, is saying when it comes to solid, glue down over a concrete, below grade, above grade, whatever, you got to take the manufacturer's recommendations. So if Jeff, he's a manufacturer, if he says yes, you can do that, you got to follow his recommendations.
Well, it's also contingent on whether or not the wood flooring itself can be glued down. I mean, if it's not finished, it's a raw wood, that's not going to work. But if it's a pre-finished solid and they recommend that you can glue it down, then yes.
Okay. Any other questions? Let me get them and then you.
If you're working with an engineered floor that the manufacturer says you can nail down or glue down, wood subfloor, what criteria do you use to determine?
The question is, if I've got an engineered floor that says you can nail down or glue down, what criteria do I use? Okay. If they want to glue down, I actually put a 1/4 inch underlayment down. Have you ever torn out a glue down over a subfloor? It does so much damage. So what we do, that's my company, we put down a 1/4 inch underlayment, and that way when they decide to tear out the hardwood, it doesn't damage the actual subfloor. I'm just tearing everything else up, but the subfloor stays intact, because if you got some good glue, you are just going to beat the heck out of that subfloor. So it makes, that's what we do.
How did you put down the 4 inch?
How do we just staple it down? Yeah, we just staple it down.
My thing is for people to know, just in case I've found it as an inspector, I've done probably 6 claims. Contractors thinking they put plywood subfloor over a urethane moisture protector and then nail through it. I just think how many poor guys have lost their shirt.
That's always a tough one. That's a tough one even in our industry because, NWFA, see, you got to look at the manufacturers. But once again, that old days, the cold tar that we spread, what happened, the concept, the thinking behind that, using a screed, pinning it down, was the cold tar would reach up around the fastener and kind of help minimize moisture passing through that fastener, So that was old thinking. Thinking is, things have changed, technology has changed, so it's gotten a lot better. So we don't, not so much that method, but you're still seeing it out there. Okay? One more question and we'll call it. Yes?
Is rosin paper a proper...
That's a good one. Is red rosin paper a considered a moisture retarder? So a good underlayment? You might as well use toilet paper. It's not. It's not. Don't use it. Yeah. 15 pounds felt. Yeah, that's recommended. They have some other products out there. NWFA in their guidelines, if you want to look up, for underlayments, there's like a UM44D. I think that's what they're anything that meets that specification, you're good to go. All right. Hey, time's up. Thanks so much. Please fill out the yellow comment sheets, whether it's good, bad. You say these guys stink. We don't want them back. But yeah, they really rely on those, so we appreciate it. Okay. Thanks. Have a great show. And you know what? Thank you.
Thank you.